quadratics are always can be written in the following form. And I know you've seen this. ax squared plus bx plus c. You guys have all seen that before. Okay? What's nice about completing the square is that it uses that standard form, if you will, of an equation. That ax squared plus bx plus c. Well, for instance, we'll just set it equals 0 because we're saying we're using our zeros. We're solving using completing the square. What's nice about completing the square is that if you forgot how to factor, if you forget how to work with radicals, if you forget how to work with the quadratic formula, which we'll talk about maybe tomorrow, completing the square will always work. It's a little bit longer to work with, but it'll always work. It'll be able to take those types of problems that you cannot factor. For example, if I have a problem that looks like x squared plus 10x plus 3 equals 0, and I wanted to solve for those zeros, that's not something that I can just factor. What times what's 3 that adds together to get 10? Not going to happen. Well, it's going to happen now. If I'm not mistaken, you guys probably did this.
Yeah. They touched on it.
You probably did it like one day or so. You might have done it just with the leading term coefficient equal to 1. You can do that with 2's when it's not equal to 1 as well. It just takes an extra step or so. What we're going to do today is we'll probably just walk through a few of these with a leading term of 1. Depending on where we're at that point, we might throw a couple in with that's not equal to 1, and then just build out of that. Okay? So let's take a look at these examples. I think I'm going to start with that one from now. Yeah. Oh, we'll use it as -3. Sorry. Rewrite that problem as put up. Bless you. And write it as -3. Okay? And whenever we're completing the square, we're going to follow the exact same process and steps each and every time. And that's why I like completing the square. As scatterbrained as you guys may think that I am, I like sequential things. I like to know the process to do something. If you'd say, hey, do this, do this, do this, okay, no problem, I'll do it. You know, it's very easy to follow instructions. That's why when I write these things out like this, I try to show you guys a way that if you just follow through this process, it'll work. All right. So in this case, we have it written as an ax squared plus bx plus c equals 0. That's your standard form of it. When you go to complete the square, you do the following steps. Move the constant. Did you see how I left a blank spot there?
Yeah.
Leave a little blank. It's a little bit of a helper. All right. Now, from here we're going to do the following. I'm going to take half of b. What's my value of b in this equation? 10. So that becomes 10 divided by 2, which is how much? Good. What's 5 squared?
25.
I'm going to add that to both sides. What I just did there, by adding the same amount to both sides, did I keep the equation valid?
Yeah.
Yeah. Now, look at your trinomial on the left. What times what's 25? You had to go to get 10. 5 and 5, isn't it? Wasn't that half of b?
What?
What's half of b?
1.5?
5.
Oh.
It's 5. So what you've done here is you've created a perfect square, with your term being x plus 5 quantity squared. You see that? Equals 28. What's nice about this completing the square is that your half of b always goes into your term in parentheses. That's your answer to that is 5. Now it's an equation that we've learned how to solve. What do I do first to solve this? I take the square root. What do I do when I take a square root over an equal sign? Very good. Do you remember what is the perfect square that goes into 28?
4.
4. So to simplify the square of 28, what do you get?
2 squared. 2 squared.
Very good, 2 root 7. So that means I have x plus 5 equals plus or minus 2 root 7. And then what do I do lastly with that 5? Subtract it. So x is going to equal negative 5 plus or minus 2 root 7. So that's your zeros for that function. Not clean numbers. Just like we were doing earlier, where you couldn't, remember you said you couldn't factor it? You could have. You just didn't know. All right, so you can factor some things. All right, completing the square. Your process is basically doing the following: take half of b, square it, and you add it to the other side. You add it in here. Your term is x plus whatever this half of b is. And if I do a couple of them, you'll see how it works out. It's very, very clean. It's the same thing over and over and over again. Half of b, square it, add to both sides. Every time. Okay? Show you another one. Once again, this is a problem where you have, what times what's positive 76, but it adds together at negative 16. Well, that's too much work. What do you think your first step is to do? Subtract the 76. So I move the 76 over, I'm left with x squared minus 16x blank equals negative 76. We okay with that? Yeah. All right. Half of b. What's half of negative 16? Okay. What's negative 8 squared?
64.
Good. So I'm going to add 64 to both sides. Now, what was that half of b value? It was negative 8. So since that was my half of b, it goes in there as my term.
Will it always work out like that?
Always. Always, always, always. Just be careful to look, if your b value is negative, you know you're going to have a negative perfect square. If the b value is positive, you'll have a positive perfect square. Does that make sense? All right, what's negative 76 and 6? It's negative 12. Oh. Now what do you do? You use the I.
2i root 3.
Very good. Plus or minus 2i root 3. Very good. So they throw this in after you have learned about imaginary numbers because, yes, when you factor something, you can have imaginary zeros. Remember how I told you yesterday that your workload just became doubled? This is what happens. It's not like your workload's doubled, just the amount of problems you can come up with. So your life just became more complex. You see what I did there?
Yeah.
Last but not least, add the 8. Can you get that? When you did this before, obviously you never had to worry about complex numbers. You probably did some radical stuff and that was about it. You might have even done it where we worked out cleanly. Okay? It's not that bad, is it? Just do this one. Do the one on the left, please. Probably right. You're probably right. On this one over here, did you have to move anything?
No.
Yay! One less step. So half of b. What's half of 4?
2.
What's 2 squared?
4.
What are you going to add to both sides?
4.
Are you playing golf? That was awful. I know. You get 3 then on the other side. So x plus 2 equals plus or minus root 3.
So you hit the wall if there's actually somebody anything.
Negative 1 plus 4.
So they know that a wall is wall.
There, what I did here is we have x squared plus 4x blank
Yeah, like.
equals the negative 1. We took half of b, which was 2, squared it, and we add that 4 to both sides. That's where I got the 3. Then lastly,
One of the things that I've told people to help make this a little bit less fuzzy, since we know that we're going to add something to both sides of the equation,
you see how I threw that little underline here? Sometimes it's not a bad idea to put it on that side as well,
especially when we get to some of the more complicated things later.
Later in the day later?
No,
Or
as in-
later in the year later?
As in, I don't know, maybe next week sometime.
Okay, that's fine then.
There will be a time when we have graphs that are called conic sections, and you'll complete the square for 2 different terms to get different equation values. So it's easier to have it written out twice. It's not bad.
It sounds bad. Yeah, it really does.
I'll show you another one. It's boring. We got time. All right, let's try one. All right, let's try this. I give up. We've actually had it the longest.
Because man, this is yeah, it's really fun to make the screen bigger. None of the humanities teachers know how to start a movie.
You had that before. You had it before here. You just gotta do this. That's
Okay. Whenever you have a leading term coefficient, correct. That's exactly what you do. The first thing you're going to do is you're always going to factor out your leading term coefficient, no matter what the number value is. Sometimes all 3 of the numbers within the trinomial are factors of it. Sometimes they're not, which means you'll have fractions. Not a big deal. All of this works the same. So in this case here, I'm first going to factor out the 3, and I have x squared minus 2x plus 4 is 0. Okay. Yes, ma'am.
You might have just explained this, but I don't think I understood. What happens if you can't find the x plus 4?
It would be you just making it a refraction.
Oh, okay.
That's all. If that middle term was 4, it was 3x squared minus 4x, it would be just 4/3 then for that middle term. And you can still take half of it. You can still square it. Okay. Now, at this point, what you want to make sure that you're doing is you're still going to follow the same process within there. But what do you have to be careful of when you add something to the other side? 3's got to carry, you multiply by 3. Okay. So notice how we factored out the 3 here. Not yet. Okay.
Wait, plus 12.
When you set these things through, if you factor out something on one, you're going to be adding something to the other side, you can go ahead and you're saying just to add the 12 right off the bat. You can do that, okay? If you want to go that route, because at this point I'm going to have to move that 4 over here to become a negative 4. Do you agree? But what did I take out of that? A 3. The reason, I guess, you know what, since we're not anywhere near conics yet, the reason I took the 3 out first is because of what's going to happen later on. We don't need to worry about that yet. So, yeah, it's okay. For right now, we're fine. Yes, ma'am?
Instead of doing that, could you just wait until you get like your final equation and then just multiply yourself by
You'll forget. All right. Now, here, yes, ma'am?
Why would we just you can't just take out
You can't just take out the 3 because you're eventually, you're paring down, for lack of better terms, the trinomial itself. So you've simplified that C value. If you just get rid of the 3 over here, it's less of a value than it started with. It's unbalanced. Bringing the 3 over with it won't make it still part of the factor. It stays balanced. If that makes sense.
But if you divided it, if you had the equation, if you divided everything by 3, it would still be count.
I see where you're going with, but what we're doing here is we're trying to pare this down into an equation. And if you divide out the 3, get rid of the 3, what's happening here when I get into my completing the square part, I don't have it as a factor of 3 anymore. So I need to keep this 3 here and here. All right. We'll finish this one in a month. We'll stop it because now I'm going to run out of time because this takes a lot longer than I wanted to go through. Yeah. Oh yeah. We'll do the homework tonight without the leading term.
Oh, yeah.
But it's with the ones. Okay. This will take longer than we have right now, and I'd rather not rush through it just to make sure we get it right. That's all. We'll finish on it. We'll finish this. We'll finish this one in the morning.
Wait.
That's it, right?
Yeah.
Oh, yeah.
All right. We'll build off of that. We'll build off that into tomorrow with that leading term. Okay.